Number 10 is an example of solving a compound inequality. There are two types of compound inequalities. There are those that use the word and the other one that use the word or. The ands are the ones that are a little bit more overt. You can't see them. But we want numbers that are both. They have to be both. Find the values of x that will make this value in here that's both less than 16 and greater than 8. So this is a both, which is the word and. So we want to make sure we find numbers that meet both those criteria. We talked about this in our lesson. In this nice convenient compound form, an and statement, we said that we could solve these simultaneously. So what we're going to do is do our PEMDAS backwards, our GEMDAS backwards. And I'm going to make sure I can get this value in here isolated for x. So the first thing we're going to do is we're going to add 4. So we're treating these as two separate equations or inequalities. There's one on the right, one on the left. So this is going to give us 12 is less than 2x, which is less than 20. Now we can get rid of multiplying by 2 by dividing by 2. So we're going to divide both sides of our inequality by 2. So that means 6 is less than x, which is less than 10. So our solution set should be all numbers that are between a 6 and a 10. So when we graph our solution set, I want to make sure we represent our two ending points, our anchor points, as 6 and 10 on the graph. And because they both are less than, open circles. And now we want to make sure that we have numbers that are smaller than 10, which go to the direction of the left. And we want to make sure that 6 is less than x, which means x is greater than 6. So we have this area where they are both less than 10 and greater than 6. So this is your and statement. So our solution set are those things that they have in common, also known as the intersection of our two number sets.